Hi guys, so I am still stuck at jury duty, so we're going to go over your 4.4 notes today on periodic trends. You should have already seen this yesterday. I had you do some online research to look at atomic radii and ionization energy, so we're going to go over that as well as something called electronegativity. You have a handout to fill in. So go ahead, I'm not going to pause on each slide, but the video can be paused in between each slide so that you can keep up with the material. Alright, so there's two trends we've already gone over. The first one is we go across a period, so looking left to right, the atomic number increases by 1 for each element because we are adding a proton to the nucleus as we go left to right across the periodic table. The other trend is as we go down a group, so from top to bottom on the periodic table, in that trend all the elements have similar properties that are in the same group. For example, fluorine, chlorine, and bromine are all halogens. They have valences of 7, and they're all very reactive as they try and get an octet. Alright, so the first trend that we're going to talk about today that's new is a trend with something called ionization energy. So for ionization energy, we're looking at how much energy it would take to actually pluck an electron off of an atom. Now what we know is that as you go across a period, so left to right, ionization energy is going to go up. The reason for this is that as you add more electrons to the outer shell, that element, that atom, is closer to having full valence. It's going to be less likely to want to give up its electrons. So it's going to take a lot more energy to pull that electron away. Whereas something like sodium, which if we remove that one electron, has a full valence in the shell below, it won't take as much energy to pluck off that electron. It will more readily give it up, so its ionization energy will be low. So overall, the trend is as we go from left to right on the periodic table, ionization energy will increase. Alright, the second portion of our trend for ionization energy has to do with looking down the periodic table. So as our number of energy levels increases 1, 2, 3, 4, all the way to 7, we're adding more energy levels. Each energy level puts more space between the nucleus of the atom, what we'll call N, and the valence electron that's very far away from it. The further away, the harder it is to hold on to that electron, the easier for that electron to be plucked off. Since it's so far away from the nucleus, the attraction from the protons in the nucleus to the electron way on the outside is lower. So taking our two trends into mind, what we know is that in terms of ionization energy, going across the periodic table, left to right, and going up the periodic table from bottom to top, shows increasing ionization energy. The overall trend then, atoms that are on the top right of our periodic table will have far higher ionization energies than atoms on the lower left side of our periodic table. So ionization energy increases going up and to the right. Alright, trend number 2 that we're going to talk about is electronegativity. So electronegativity, I like to focus on the electron part of it. It's how much this atom loves electrons. So another way of looking at that is how close is that atom to gaining full valence if it takes an electron from another atom. So what this means, atoms like fluorine, those on the very right top part of the table, they're just 1, maybe 2 electrons shy of having full valence. So they're going to have a very high electronegativity. They're very close to gaining that octet. So we can add here high electronegativity. We'll put En for electronegativity. Whereas at the other end of the table, the bottom left, and even the top left, with the exception of hydrogen, these atoms want to give up an electron to clear out their outer energy level to drop to the level below. So they don't really want any more electrons. So their electronegativity is going to be very low. So just like ionization energy, electronegativity increases as we go across the periodic table, left to right, and as we go from the bottom of the periodic table up to the top, for an overall trend that favors the top right side of the periodic table. Another way to look at this, still the same trend, is instead of looking at it from top to bottom, where electronegativity increases, we can focus on reading the periodic table top down, in which case electronegativity will decrease. It's the same thing, just said in reverse. So as we go down the periodic table, atoms get bigger, we add more energy levels. It's hard to hang on to those electrons that are very far away. At the top of the table, atoms are very small. Only 1 or 2 energy levels around that nucleus, so the electrons are very close to the nucleus, very easy to hang on to. There's a lot of attraction between the protons in the nucleus and the electrons in those nearby energy levels. Alright, the last trend we're going to talk about today is atomic radii. Now, radii, maybe you remember from a math class, if you're looking at a circle, it is a distance from the center of the circle to the outside. Well, an atom is spherical in nature, so atomic radii is the distance from the nucleus at the center to the valence electron all the way on the outside. So it's that same idea, just trying to measure how big it is from the center to the outside. What we know, our first trend, is the atomic radius or size will increase as we go down a group. So as we look with each increasing energy level, we add another ring of electrons, meaning we add more distance from the nucleus to the outer electrons. So atoms get bigger as we go down the periodic table. We can visualize this by drawing kind of a replica of the atom. So if we put our nucleus in the center, hydrogen would have 1 energy level, small. Lithium would have 2 energy levels, bigger. Sodium, 3 energy levels, even larger. And we can keep adding and adding energy levels and see how the atom will get larger. Again, here's a much nicer, much neater drawing of what I just showed you on the last slide. Lithium, which is in period 2, or has 2 energy levels, is larger than hydrogen. But sodium, which has 3 energy levels, 1, 2, 3, is much larger than lithium just by having more energy levels. So atomic radii will increase as we go down the periodic table, top to bottom. The second part of our trend for atomic radii is looking as we go across the periodic table from left to right. As we go across, something interesting happens. Because we add more protons, they're going to be more attracted to those negative electrons, and they're going to actually pull them in closer. So within the same period, so like if we look at period 2, they're going to get smaller. Because by the time you make it over to, say, fluorine, fluorine has the same number of energy levels as lithium, but it has more protons. Because fluorine has more protons, they will pull more strongly on the electrons. It's something we call a Coulombic attraction. C-O-U-L-O-M-B-I-C. BIC. It's what makes two magnets attracted to each other. It's the attraction between something that's positive and something that's negative, is a Coulombic attraction. So those positive protons really like those negative electrons, and when we have a lot more protons than their counterparts earlier in the period, they will pull more strongly on the electrons, drawing them in closer, making the atoms smaller. In summary, we have three major trends that we talked about today. Those being atomic radii, ionization energy, and electronegativity. Electronegativity increases as we go up the periodic table and left to right across the periodic table. There's an overall trend from francium up to fluorine. Fluorine having the greatest electronegativity. Ionization energy is a very similar trend. It increases as we go up the periodic table and as we go across left to right. Meaning francium, again, has the lowest ionization energy, the least desire for losing its electrons. And fluorine and the noble gases have the greatest desire to keep their electrons. So they have much higher ionization energies, much less likely to give them up. The last one we looked at, atomic radii, runs opposite of these two. Atoms get larger as we go down the periodic table, and they're larger to the left side of the periodic table, meaning the overall trend for atomic radii is down to the left, making francium the largest atom with the lowest ionization energy and the lowest electronegativity. Fluorine and the noble gases are the smallest atomic radii with the highest ionization energies and the highest electronegativities. Okay guys, so that's it for our notes today. Be sure to check in your textbook or online. You can look at the Crash Course YouTube videos to help you with this as well. And as always, you can send me an email. Hopefully my jury duty will be done soon, and I will be back in the classroom to continue teaching you.